Okay, it's an interesting question. There's four terms, and I want to solve for theta, where theta is between 0 and 2 pi. Now, when you see four terms, the first assumption is maybe you could factor it by grouping. I notice the first two terms, if you try to group those, I don't see any factors in common. All right. Now, so what I'm going to do is what I normally recommend to my students: if you see functions other than sine and cosine in your problem, rewrite the other function in terms of sines and cosines. All right. The other thing I recommend to students sometimes is if they see a cosine in the problem, write it in terms of sines, but that doesn't look possible at this point. All right. I could use a cofunction identity. I just don't think that's going to go anywhere. The other possibility I see is possibly this might be related to product sum formulas. But let's just try one thing at a time. And the first thing I try to do is rewrite that tangent function in terms of sines and cosines. So root plus root 3. This can be sine theta over cosine theta, and then minus 3. Okay, so what I do notice now is this term here and this term here, just by a simple rearrangement, will have something in common. So let me put that down. So 2 sine let's see, plus root 3 sine theta over cosine theta. You may wonder what we're trying to do. We're trying to factor the problem. If I factor it, there's a good chance we'll be able to use the zero product rule. But again, the assumption is that things will work. All right, you could write a problem that doesn't factor, by the way. Now, if I look at these first two terms, the only thing I really see common between those two terms is the sine of theta. So I'm going to factor that. You get sine theta times, well, I get a 2 there, and then I get plus root 3 over the cosine of theta. I'm looking at these two terms now, and I'm going to factor out, well, you know what, I'm looking at the 2 plus root 3 over cosine theta. So first thing I want to factor out is a root 3. And I'm going to factor out the cosine of theta. All right, let's put that down now. So what would you get the first term? You get 2, which is what I wanted to get. All right, I want to get that 2. I'm hoping I get the second term of plus, well, let's see, I would need a root 3 there, right? I'll check this out, by the way. And then over cosine theta. All right, before I sing victory, I want to point out that I want to distribute this across those two terms and see if I get those two terms on top, by the way. You would get minus root 3, you'd get a 2, and you get cosine theta. Don't forget the first term. The next one I get minus 3, and the cosine theta would disappear. And this is somewhat good news because I can now factor this. There's 2 terms. There were 4. Now there's 2 terms. So I'm going to factor out the factor 2 plus root 3 over cosine theta from the first and second term. And we left off with sine theta minus root 3 cosine theta. And that equals 0. Now I have a product. I'm going to use the zero product rule to try to solve that. So I'm going to say one thing at a time. So I want this thing to be 0. Let me write this down for you. Sine theta minus root 3 cosine theta. I want that to be equal to 0. That means sine theta would equal root 3 cosine theta. I'm safe in dividing both sides by cosine theta because they're not simultaneously 0. So what do you get here? Root 3, and then you get the tangent of theta. And this is the proper form is what I want. So what I want to do is I want to just emphasize that if I were looking at this thing, I'd draw one cycle of the tangent function, and then I'd wonder when the ratio becomes root 3. And let me just put the reference triangle down for you. So root 3, that would be 1. This would be 60 degrees. That would be 2. So what do I know about this over here? I know the theta is going to be 60 degrees, but it keeps repeating itself every, well, let's see the cycle of that. That's going to be every 180 degrees, right? Where k is some integer. I will go back to radian measure, by the way. But the bottom line, they said that the theta was between, let's go back over here, between these two numbers over here, which means the theta is between 0 degrees and 360 degrees. I will go back to radians later, by the way. So what do you get over here? You get 60 degrees. That's one possibility. The other possibility is 240 degrees. All right? Let me write this down in radian, though. And what are you going to get? Well, 60 degrees is going to be pi over 3. 240 is actually 4 times that number, so 4 pi over 3. All right, the other one's a little more complicated. Is this guy over here. So same thing, write down 2 plus root 3 over the cosine of theta. That equals 0. We're using the zero product rule. So I would get root 3 over cosine theta is equal to minus 2. Or I get minus root 3 over 2 is cosine of theta. Very recognizable. And what I mean by that, I'll put it down for you. It's another reference triangle, and I'll put the curve down as well. This can be a reference angle. The reference is going to be, this will be root 3, this will be 2, this will be 1, and this is 30 degrees, by the way. I'm not saying the angle is 30 degrees, I'm saying the reference is 30 degrees. What I like to do is draw the cosine curve, and the cosine curve looks like this over here. And that's on its cycle between 0 and 360 degrees. What happens over here? Well, it hits it here, that's one spot, and hits it there, it's one spot. And you may wonder what these are. This is between 90 and 180, and the other one's going to be between 180 and 270 degrees. I know I didn't do a great job of drawing those things, but it's supposed to be zeros there. Anyway, let's take a look at this over here. So if it's between 90 and 180, the reference is 30. So what does that mean? This angle here would be 150 degrees. What's this angle over here? Well, it's between 180 and 270. Its reference is 30. So 180 and 30 is 210 degrees. All right. I want to point out these are multiples of 30 degrees as expected. This is 5 times 30 degrees, and this can be 7 times 30 degrees. All right. What's the number there? Well, 30 degrees is going to be pi over 6. So this will be 5 pi over 6, and this will be 7 pi over 6. All right. So I found my answers, and I don't care what order you put them down in, but I'm going to put them in the order that I'm seeing them. Pi over 3. That one's done. The next one's going to be 5 pi over 6. That one's done. 7 pi over 6. That one's done. And then 4 pi over 3. And we're done. In the answer key, I will post a visualization of those 4 answers for that particular problem. Thank you for paying attention.